Hi everyone, and welcome to our next tutorial on Tinkercad. In the last video we took a look at analog inputs and how we can use a potentiometer and a varying voltage and send that into Arduino as an analog input. We've got the same potentiometer here set up, and we are sending the input from the potentiometer into A0. Remember, that's a range from 0 volts to 5 volts that it's going into A0. Now, what we're doing is we're sending a signal out from the Arduino board from pin 6. And if you look really closely at pin 6, it has this symbol beside it. That's the tilde symbol, and what that symbol shows is we can have what we call a pulse width modulated signal coming out of the Arduino board. And basically it works like this. The Arduino board doesn't have the ability to send out a analog out of, say, 2 volts or 3 volts or 4 volts. But what it does do instead is sends out a pulse width modulated signal, which basically looks like this here. It's a square wave, if you will, that is either putting out at any one time 0 volts or 5 volts, and you can see that here. If the pulse width modulation is 0, that means it's sending out is 0 volts, and it looks like this here. But if it's sending out a pulse width of 25%, what that means is for a specific period of time it's 5 volts, and for a specific period of time it's 0 volts. In other words, it's 5 volts for 25% of the time, and it's 0 volts for 75% of the time, and that signal quickly changes off and on in this fashion over and over again. If it's a 50% pulse width modulated signal, that means it is 5 volts for half the time and 0 volts for the other half the time, and again it fluctuates that up and down very quickly. If it's a 75% duty cycle, that means it is 5 volts for 75% of the time and 0 volts for 25% of the time. If it is a 100% duty cycle, that means it is 5 volts constantly. So as you can see, at any one time there's not a constant 2 volts, it's not a constant 3 volts, but instead we have this pulse width modulated signal that's on or off a certain period of time. If you notice here, it does have the average output voltage, and we could say that over a period of time the average output DC voltage would look like this here. So if we make this turn off and on very, very quickly, we would get something that looks like an average DC voltage out if we measured it with a multimeter. If we had a 50% duty cycle, that DC would be even higher. If it was a 75% duty cycle, it would be even higher. So that's the way a Arduino sends out a signal through these specific pins here that we're going to use for analog out. They must have the tilde symbol beside them. So if you look closely, you can see a tilde by pin 11, pin 10, pin 9, pin 6, pin 5, and pin 3. So we can use those anytime we want to have a pulse width modulated signal come out of those ports. So let's take a look at it. If we take a look here at the code, we're basically inputting the analog value from the potentiometer into A0. So that is the input. And what we're going to do is send an output to pin 6. And all we're going to do inside void loop is we're going to read the analog value coming in from A0, we're going to put it into a variable called input from plot. And then we are simply going to do an analog write. Notice it's not a digital write, it's an analog write to pin 6. And what we want to send out is the input from plot. So this number will vary depending upon what it sees coming in from A0. What do we mean by that? In other words, it will be reading some value between 0 and 1023. That will determine what is sent out. So if we take a look and run this simulator, what it looks like coming out is the pulse width modulated signal. And I can see as I change my potentiometer, in other words, I'm changing the voltage on the input of A0, that is changing the output on port 6. And I can see that through the pulse width modulated signal that comes from that. So if we take a look at this circuit here, and we can see that we have the same potentiometer. I put in a voltmeter just to read that value from the potentiometer. But this time, what I've done from port 6 is I'm trying to drive an LED circuit in series with a 220 ohm resistor. So all I'm doing is I'm taking the value from A0, putting it into the variable input from plot, and I'm doing an analog write to port 6, taking the value input from plot. Remember, that's some value between 0 and 1023. What does that do when I actually run the simulation? Well, it's a little bit hard to see, but we'll try to show you what's happening here. Although, like I said, it's difficult to see, but what it's doing is it's actually dimming the LED. So I can make it brighter or I can make it dimmer based on the pulse width modulated signal that's coming out of pin 6. All I'm doing is I'm turning that port off and on very quickly, and that's what is giving me the dimming effect. What you're going to do in the assignment is simulate something similar to this, but not exactly. What I've done with this circuit in this code is I've used an if-else if condition. And I'm driving two LEDs. I'm using the value from the potentiometer going into A0. And I know that that value going into A0 is creating some binary value in range from decimal 0 to 1023. So what my code is doing is saying the following. If the input from the plot is some number less than 511, then what I'm going to do is I'm going to turn on the red LED and the green LED is going to be off. If that input is greater than 511, then I am going to turn on the green LED and turn off the red LED. So if I was to run the simulation, it looks like this. You can see here that sometimes the voltmeter glitches, but it does reset. And you can see that if I'm below 2.5 volts, so if I'm over on this range here, that means that the input value that the Arduino sees is from 0 to 511. But once I get past on this side, you can see that the green LED turns on. In other words, what it's reading in the Arduino is some value greater than 511. What your assignment is to create 3 LEDs, not 2, but create 3, and using this same setup and using if and else ifs, we are going to have a red LED a green LED, and a yellow LED. In other words, instead of having 2 as I do, you're going to break this up into 3 ranges. So those ranges are equal in value. You're going to have to do the math and figure out what those numbers are. But as I rotate this around, it will either turn on a red LED, a green LED, or a yellow LED. That's your assignment. That's it, everyone. Take care. We'll talk to you soon.